Okay, here we are for another video. Okay, so the thing I've been working on since the last update was a scene graph. What is a scene graph? It's basically the way that we handle multiple objects that need to have a sort of like a child-parent relationship. So for example, if you think of a car has a steering wheel and an engine, and it's got the body of the car and the wheels. And as you can think of the car frame as sort of the core object, and as that moves around, other things are attached to it and they're forced to move and rotate accordingly. So there's two types of rotations that I'm mainly interested. Well, there's two types of rotations that we care about. One is a geosynchronous rotation, meaning that as the parent rotates, the child is rotated around it. And the other type is tidal lock, meaning that the same face of the child always points towards the parent. So example of a geosynchronous relationship, think about a satellite around Earth. If a satellite is maintaining a geosynchronous orbit above Australia, it will continue to stay above Australia as the Earth rotates. Whereas if it stops maintaining that kind of orbit, then it will tend to drift westward over Indonesia and Africa and America, and it will keep going around as the Earth goes around. A tidal locked relationship is exactly like the moon. The same face of the moon is always pointing towards the Earth, regardless of where the Earth is or where it's pointing. So in the 5 ships you see in front of you, only the middle one is controlled by me. Its parent is the origin 000, and the 4 on either side of it have got a different kind of relationship. So there's 2 types of relationships, tidal and geo, and we can just simply true or false those, which gives us a net total of 4 different relationships. The one on the far left has got no tidal or geo relationship. So its only relationship with the parent is its physical location. And we'd use that in formations. For example, if I've got some soldiers and they need to be able to turn independently but maintaining the same spot in the space, that's what I'd use it for. Next one along is a tidal lock, but there's no geosynchronous orbit. So this is used, for example, the wheels of a car. You can imagine that there's a front and a back wheel. They need to turn the same speed. So I'd calculate the rotation from one of them and just share that rotation along with all the other wheels. Save me some calculations. Next one along is the player controlled unit. The next one along after that has got a tidal and geosynchronous orbit. So this means it always maintains the same position and it's always going to have the same side facing. This is one of the 2 types of rotations I will use a lot, particularly turrets on tanks or spaceships need to be able to move in accordance with the thing that's essentially carrying it. The one on the far right, there's no tidal lock, so the object is free to move around, but it's still orbiting around the parent. And this is, imagine what the moon would be like if it rotated in this. Actually, no, the Earth rotating around the sun is a good example of this last one. As we're turning, we've got different facing the sun. Alright, that's all for now. I'm going to take a break from the engine for a short while and work on some Unity software. When I get back, I plan to work on 2D collision detection and adding monsters to actually shoot. That's all for now. See you next video.